Okay, so we're real quick going to talk about bar notation, okay, and then we're going to kind of get into the crux of this lesson. So as we've mentioned before, bar notation, we use that when we have a repeating decimal. We're going to use a bar over top the number or numbers that repeat so that someone knows that it's a repeating decimal without having to put all of these dots or show the repetition in that way. So very quickly, if this was what we saw, 0.54545454 repeating, to write this as bar notation, we're going to write 5400s and we're going to put a bar over top the 5 and the 4 to show that both of those digits repeat. Where kids sometimes get into trouble with something like this, and something you want to be careful of, depending upon if you're using a calculator or what your calculator says, some kids will end up doing something like this, where they say 545, and then they put a bar over that, okay? The problem is what is repeating here is not 545, 545, 545, because if that were what was repeating, this is what it would look like, okay? And that is not the same thing as this. So you want to make sure that you are correctly indicating which digits repeat so that you end up with the same sort of pattern, okay? And then you're indicating that. Same thing here. So here we have 0.5833333 repeating, okay? When we write this decimal, we're going to include the digits that don't repeat because they're part of the number, okay? So we have 0.583, and then our bar notation is only going to go over the 3 because that is the digit that is repeating. And you always just want to be careful. Make sure where you're putting this bar, you're being very specific about which values are repeating and which are not. So we want to make sure we're very clear when we use that bar to identify a repeating decimal. Now, to put this into practice, we should remember from chapter 2 that if we had a fraction, let's say the fraction was 2 11ths. Now we're going to change 2 11ths into a decimal. So I'm going to take 2 and I'm going to divide that by 11, okay? Maybe you're using a calculator, but we're going to go ahead and do this without a calculator. 11 is not going to go into 2. So what happens here is we're going to add a decimal point. When we divide with decimals, we're immediately going to pop that decimal point up into the quotient. And then we're able to add zeros here so that we can do our division. How many times is 11 going to go into 20? Okay, well, 11 will go into 20 one time. That's 11. When we subtract, we get 9. If we add another 0 and drop it, how many times does 11 go into 90? That number is going to be 8. 8 times 11 is 88. When we do 90 minus 88, we're going to get 2. 2 is smaller than 11, so we can go ahead and add another 0 and drop it. How many times does 11 go into 20? Well, if you recall, we did this originally. 11 goes into 20 one time. 1 times 11 is 11. 20 minus 11 is going to be 9. If I add another 0 and drop it, again, I end up with 90. We're taking 11 into 90 again. So 11 goes into 90 8 times, which is 88. If I would subtract, I get 2, okay? And again, 2 is smaller than 11. That's sort of what we had last time, okay? So again, what we see here is a pattern emerging. Decimal point, 1818. If we continued, it would go 1818 again. So what we have here is a repeating decimal. So we're going to put 1800s, and we're going to put bar notation over the 1 and the 8, because both the 1 and the 8 repeat in this particular situation. So there's a quick example reminder of bar notation. Okay, so continuing our discussion with rational numbers. Okay, this is the first example in your book where we are taking a fraction and we're going to write it as a decimal to show the rational number. Okay, because remember, fractions and decimals, especially if they're repeating or terminating decimals, they are rational numbers. So if I have the fraction 5/12, okay, we should remember we want to change a fraction to a decimal. We do that by division. If you do this by hand, okay, if you do this paper pencil, this is what's going to happen. You do 5 divided by 12. 12 is not going to go into 5, so you add that decimal point and pop it up, okay? Now we can start annexing zeros to the end of this to take care of the division process. 12 goes into 54 times, which is 48. When you subtract, you get 2, which is smaller than 12, and you bring down the 0. 12 goes into 20 once, which is 12. When you subtract, you get 8. 8 is smaller than 12, so we would bring down the 0. Now, 12 goes into 80 6 times. 6 times 12 is 72. And when you take 80 minus 72, you get 8. Less than 12, bring down the 0. Now we're dividing by 80 again. So you see what this sets up is we're going to be taking 80 divided by 12 repeatedly. Okay? That means we're going to end up with 0.416666666666 repeating. Okay? We're going to write that as 416 thousandths with a repeating 6. Very easy to see that repetition, that the decimal repeats when you're doing it by hand, okay? If you use a calculator, which probably a lot of you will do, and if you take 5 divided by 12, this is what the calculator gives you. 0.41666667. There's a 7 at the end. Sometimes kids will not recognize what has happened here. So when the calculator says this, 0.41666666, and then it ends with a 7, why do you think that is? Why would the calculator get a 7 at the end, where if you did it by hand, it would continue to give you 6s? Well, what the calculator does is it automatically rounds your answers, okay? So what the calculator knows is that the next digit was going to be a 6, right? So if this digit is a 6 right here and you round this, okay, we underline the 6. The 6 tells you to bump this 6 up to a 7. So the calculator rounds your answers. You have to recognize that with the calculator because some kids then don't realize that, yes, just because this ends with a 7, okay, so 667, this is still a repeating decimal. This decimal repeats. This is 0.416 with a repeating 6. It's the same answer that you would get here, okay? You have to be able to get the same answer when you do the process by paper pencil, by hand, you do it on your own, or if you use the calculator, you have to understand that the calculator is going to round that final digit. So you cannot look at that and say, oh, well, all of a sudden it went to a 7, so this is not a repeating decimal. It is a repeating decimal. The calculator just rounded the answer for you. So you have to be very, very careful of that if you're using a calculator. Okay, so we look at the examples really quickly on page 581 at the top. I'm only going to look at A and B here quickly. And I'm going to assume that you're using a calculator to do these. Because if we look at letter A and we have the fraction 1/6. Again, to change a fraction to a decimal, you divide numerator divided by denominator. This is another way of writing a division problem. 1 divided by 6. If you put into your calculator 1 divided by 6, your calculator is going to do this. 0.166666666, but it's going to end with a 7. So again, you have to recognize that the calculator rounded this answer, and it rounded that final digit up because 6 is 5 or higher. So when you go to show this using bar notation, your answer is actually going to be this, 0.16 with a repeating 6, because technically we should know that that 7, again, would have been another 6 and another 6 and another 6. They just rounded it. Same thing with letter B, 8/9, okay? So in 8/9, we're going to take, again, to change a fraction to a decimal, numerator divided by denominator, 8 divided by 9. So we're going to end up on our calculator with 0.88888888889, because again, the calculator rounded that answer for you. So we have to recognize that this 9 wouldn't be a 9 except for the fact that the calculator rounded it. So your answer here is actually going to be 8/10 repeating, with a repeating 8, okay? So if you're using a calculator, you have to make sure you're aware of that and being careful with that. Okay, so now we need to look at some examples where we have to write negative fractions as negative decimals. And sometimes those decimals might terminate, sometimes those decimals might repeat, okay? So if we look at example number 2, we have a negative 2/9. We're gonna do the same process as if this was just 2/9, we just have to remember to stick a negative sign in front of the decimal. If it's a negative fraction, it's going to equal the negative decimal, okay? So again, you can go ahead and do the 2 divided by 9 here, okay? Add the decimal point, pop it up, start adding your zeros. 2, 18, lo and behold, here's what happens. 9 goes into 20 again twice. 2 times 9 is 18. We have 2 left over. So you can kind of see the pattern here. We're going to get a repeating 2, okay? We have to make sure that our decimal is negative, though. This is negative 2/9, so that when we write our decimal, it's going to be equal to negative 2/10 repeating, okay? So negative 2/9 is equal to negative 2/10 repeating, okay? So again, you can do that via a calculator, you can do that paper pencil, whatever, but you're still going to get the same response. Negative 2/10 repeating. So just make sure you remember the negative sign. Same thing over here. Now we have a whole number. So there's 2 ways you can handle when we have a whole number. One way is to go ahead and change this to an improper fraction, okay? So for example, negative 2 2/3 is going to be the same thing as negative 8/3, okay? Because 3 times 2 is 6. 6 plus 2 is 8. So if you remember, if you go around the clock and you multiply this and you add that, okay, 3 times 2 is 6, 6 plus 2 is 8. Negative 2 2/3 is the same thing as negative 8/3. We just turned it into an improper fraction, okay? Now, what we can do is the same thing we did over here. Go ahead and drop divide. It's always numerator divided by denominator. So we could take 8 and divide that by 3, right? Now, what's going to happen here, 3 goes into 8 2 times. That gives us 6. We subtract and get 2. Now is when we would add our decimal point and pop it up. And now is when we would go ahead and start adding on zeros. 3 is going to go into 26 times. 6 times 3 is 18. So when we subtract, we're going to get 2. We can add another 0 and drop that. Okay, again, 3 is going into 20. Again, that's going to go in 6 times. We get 18. So you start to notice that this is going to repeat because we're going to end up with the same division problem over and over again. Since this is repeating, okay, we have 2.6. We're going to put the bar notation over the 6. We also have to remember the negative sign. So this is going to be negative 2 6/10 with a repeating 6. Okay, so negative 2 2/3, okay, is going to be equal to negative 2 6/10 repeating. All right. Now, the other way you can think about this, if you don't want to change this into an improper fraction, is you can keep it separate. Okay, so you can just say, all right, so I have a negative 2 as my whole number. That's not going to change in this case because this fraction is proper. When it's a proper fraction, you're not going to end up with any more whole numbers. So you can just say, okay, we got negative 2, and then go ahead and take 2 divided by 3, which is going to give you your 0.6 repeating. So as long as you can kind of put them together, negative 2, 0.6 repeating. 2 divided by 3 would be 0.666666. Okay? So you can change it to an improper fraction. You can kind of piecemeal it, keep the whole number sort of separate from the fraction and do it that way. Okay, so when it's negative, you just have to make sure you are remembering to include the negative sign with it. Okay? Okay, we're going to finish off here quickly with just some examples from the book. We're going to look at letter D and letter F from page 581. So I have negative 1/4 here. I want to write that as a decimal. Okay? So again, to change a fraction to a decimal, you divide numerator divided by denominator. 1 divided by 4 is going to give you 25/100. Okay? We just have to make sure we use the negative sign. So this answer should be negative 25/100. So negative 1/4 is going to be equal to negative 25/100. Okay? Now we jump over to letter F. In letter F, we have a whole number and a fraction. We call that a mixed number. So in the case of mixed numbers, one way you can handle this is to go ahead and change this to an improper fraction. So we could change this to 13/6. Remember, to change an improper fraction, we're going to multiply the denominator times the whole number. 6 times 2 is 12. Add on that whole number numerator. So we have 12 plus 1, which is 13, okay? So that's where we got negative 2 and 1/6 as an improper fraction would be negative 13/6. Now, if you want to use your calculator or you want to do it by hand, whatever, this is what you're going to end up with if you take 13 and divide it by 6. 13 divided by 6 is 2.166666667. Okay, so we have to remember a couple of things here. First of all, this is negative. So it's going to be negative 2.16. And we also have to remember that that ending 7 on the calculator just means they rounded that final digit from a 6 up to a 7. So this is still a repeating decimal. So it's going to be negative 2.16 with a repeating 6. Okay? So that is going to be the decimal equivalent of negative 2 and 1/6. Okay? So just something to keep in mind with your rational numbers. Just make sure you're paying attention to signs. Make sure when it's a mixed number that you're making sure you include the whole number with it. So just some things to keep in mind there with rational numbers. Okay, thank you.